All right, we're still on Chapter 2, Section 2.6, Part 2, Solve using algebra, define a variable, write an equation, solve, and check. We have another mixture problem, a percent mixture problem, number 4. How many grams of water must be added to 50 grams of pure acid to make a solution that is 40% acid? All right, so first of all, water, we're going to assume that's just pure water, which means there's no acid in it or anything else, hopefully. All right, but the picture is similar. We start off with we're going to mix water with pure acid, and we're going to get some mixture. So we have to know how much of each to put in this container. And so I'm going to write underneath the percent concentration of acid in each container. All right, in water, how much acid is there? None. 0. Okay. Pure acid. What does that mean, pure acid? It means it's completely 100% acid. And how do you write 100%? 1. The entire container is acid. In the mixture, we want to end up with only 40% acid. And how do we write that? 0.4. Now, you can write 0.40, but it's unnecessary. So the mixture has the 40% acid. All right, now we need to fill in how much is in each container. And what do we know? We've got 50 grams of pure acid. So we know there's 50 grams here. And what we don't know is how much water. So let's let that be W for how much water. Remember, you could use any variable you'd like. So I've got W grams of water plus 50 grams of acid. So if we're pouring them together, we're just adding W plus 50. We're not concerned with which is how much acid is in there, just how much, stuff, how much liquid is in each of the containers. So now we're going to figure out how much pure acid is in each container. All right, how much acid is in the water? 0. You could write 0 times W, but of course in water we know there's no acid. Of course that's the idea. I hope that's it. Now how much pure acid is in here? Well, how much pure acid is in all that pure acid? The entire container, 50. Again, you can write 1 times 50, right? But of course 1 times 50 is 50, just like W times 0 is 0. All right, now how much is in the mixture? Because we're adding these together, right? So the amount of acid in each of these containers should end up being the same amount of acid over here. So I'm representing 0 plus 50 is how much acid there's still going to be from these two containers. How much acid do we want in the mixture? We want 40% of W plus 50, so that's 0.4 times W plus 50. And what we're saying is if you're pouring in no acid from here and 50 grams of acid from this container, I should have the same amount of acid after I mix them together. So these must be equal. So I've got 0 plus 50 is just 50. 50 equals 0.4 W plus 50. Now again, if you want, you can work with, that 50 doesn't look very good. Let's write that better. You can leave it with decimals and deal with decimals. I like to get rid of the decimals, so I'm going to multiply both sides by 10 to move this decimal 1 to the right. So I'm going to multiply both sides by 10. All right, so when I do 10 times 50, I'm going to get, so in other words, just to show you what's going on, I'm multiplying that side by 10, and I'm multiplying that side by 10. So I have 500 equals, well, I'm going to just do the 10 times the 0.4, and that does not also get multiplied by what's inside the parentheses. Be very careful here. When you have 3 numbers to multiply, you don't multiply it too much. I think this 0.10 is like out of the range here. I'm going to multiply it by like this, 10 times the 0.4. So you just do the 10 times the 0.4, that's the 4, and then you still have to multiply that answer. Okay, so we've got 500 equals 4 times W plus 50. There are a couple ways to solve from here. I'm going to do a traditional way where we just first do the distributive property on the right. And 4 times 50 is 200, and subtract 200 from both sides. Which is 300 is 4W. And then we could divide both sides by 4. And 300 divided by 4 is 75, so we should end up with W equals 75. So we've got what W is, and hopefully that's the right answer, but of course we have to check. So here was our original problem. How many grams of water must be added to 50 grams of pure acid? And this was the picture we came up with. All right, but now we know what X is. We got X equals 75. So now we can actually put in that we know how much water there is. There was 50 grams of acid. And so in the mixture, I've got 125 grams. 75 plus 50 is 125. So this was the water, the acid, and the mix. And each had a certain concentration of acid, which was 0, 1, and 0.4, right? Okay. So on the left-hand side, that tells you, let's figure out how much acid was on the left-hand side. Here, well, there was no acid from the water, right? And I had exactly 50 grams of acid. So I know there's 50 grams of pure acid here. From, whoops, sorry, that's the next problem. So the pure acid here is just 50 grams, right? Because that's all I started off with mixing water and 50 grams of acid. So I've got that. Now, how much pure acid is here? Well, it's 40% of 125. So 0.4 times 125 grams. And you do that in your calculator if you want, or any other way. You could write that as 2/5 times 125. That also equals 50 grams. So I see I do end up with the same amount of acid, whether I mix these two together or I look at the final container. So then the final question of the day is, how much water should I use? That was the question, and I look at the picture. Use 75 grams of water. Still working with application problems from Chapter 2, Section 2.6. Number 2, solve using algebra. Define a variable, write an equation, solve, and check. All right, number 5. The price of a book increased by 10%. If the book originally cost $89.90, what is the new price of the book? All right, so what we're looking for is the new price of the book. So how about we let N be the new price of the book? All right, so now we need to solve the equation. How would you get the new price? You'd have the original price, which is $89.90, right? And then there's a markup, right? It increased by 10%. What does that mean? It's 10% of what the book originally cost. So how do you write 10%? You can write 0.1 times, or 0.10, $89.90. I'm writing right now the numbers in dollars and cents since we're dealing with many, but you could have written 89.9 both of these times. And that tells us what the new price of the book is. That's what N's going to be. You have to take the original price, you're going to mark it up 10%, and you're going to get a new price. I'm sure a lot of you could have done this without algebra. So we have $89.90 plus, what's 10% of that? $8.99. So what we're doing is adding $89.90 and $8.99, and that's all there is to this problem. So you should get $98.89, right? And it is a word problem, so you want to say, what's the new price of the book? You would just say the new price is $98.89. You do want to put the dollar symbol in there, and the dollar symbol goes in front of the numbers, right? And that's number 5.